Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good evening. So thank you very much for joining for today's session. So kita akan continue yang kita sambung awal dulu. So minggu lepas kita cerita tentang platform Google Cloud. So Google Cloud ni dia macam nombor 2 dengan nombor 3 lah. Dia compete dengan Microsoft Azure. So for this session, kita nak tengok macam mana kita guna Google Cloud untuk build application. So application ni tak kisahlah either mobile application atau web application. So dua-dua penting lah. So web application masih lagi ke industri kita masih guna web application. Tapi untuk end user banyak dah. So macam kita lah, kita dah jangan depan komputer dan kita banyak dekat mobile. So mobile application 90% lah. Kan? So untuk end user application memang mobile application penting. So macam mana kita nak guna cloud application untuk build our apps. So welcome to use Google Cloud to build your apps. So in this module, we will focus on leveraging Google Cloud resources and serverless managed services to build application. So yang penting ni cloud dia nak memudahkan. So yang penting kita nak guna servis apa, infrastructure apa yang dalam cloud, and then juga serverless. Serverless maksudnya kita tak payah hustle lah. It's untuk end user ataupun customer baguslah. So untuk expert macam kita ni, kita nak memudahkan orang lain lah. Okay, serverless maksudnya kita tak perlu manage banyak. Maksudnya yang di belakang tu, hopefully kita lah kan yang manage semua expertise tu. Yang customer depan dia hanya terima result je. Okay. So far sekarang kita masuk modul 3. Modul 3 penting ni. Ni study boleh. Ada yang masuk exam lah. So far in this course, we've learned what Google Cloud is and found out why we should have a solid platform before beginning a Google Cloud transfer. So in this module, we will learn how to build apps directly in Google Cloud. So the objective of this module is first explore the role of compute options in the cloud, describe building and managing virtual machines. Selanjutnya virtual machines, maksudnya benda yang kita dah convert pada digital lah. So kat dalam Google Cloud pun dipanggil virtual lah, virtual machines. And then explain building elastic application using auto scaling. Auto scaling kita tahu nak scale up and down, and then explore platform as a service by leveraging app engine. So kita dah belajar platform as a service ni macam kita tak nak sentuh sangat tentang server machine and so on. Kita nak buat kita punya coding application je. And then we discuss about building event-driven service utilizing cloud function, and then explain containerizing and orchestrating application with Google Kubernetes engines. Okay, and this agenda shows the topics that are in the module, compute option in the cloud, exploring infrastructure as a service, lab, and so on. Lab, and then set up. Ini penting. So study yang ni. Let's start with the first topic, compute option in the cloud. So compute kalau macam dalam Google Resource, EC2 lah. Apa ni? Compute, elastic compute computing. So EC2. So dalam Google Cloud, for general workloads that require dedicated resource, for your application, compute engine is a good option. Kalau dalam dalam Google Amazon dia EC2. Kalau dekat Google Cloud, compute engine dia bukan benda sama lah. So if you're looking for a platform as a service, App Engine is a good option. Cloud Functions offers a serverless options for triggering code to run based on some kind of event and to run containers on a managed Kubernetes platform. You can leverage GKE, Google Kubernetes Engine. We will discuss each of these compute services during these modules. So next we will discover how to build and deploy applications with compute engine. So compute engine or infrastructure as a service. So infrastructure kan dia paling atas sekali, maksudnya kita nak manage kebanyakan benda yang dalam tu, contohnya average lah, database ke apa semua kita nak manage. So dia bukan macam platform service ni kita nak manage application, kita nak manage application yang belakang tu dia pakai apa semua kita tak nak fikir. Okay. So compute engine is ideal if you need complete control over the virtual machine infrastructure, need to make changes to the kernel, such as providing your own network or graphics drivers to squeeze out the last drop of performance, or if you need to run a software package that can't easily be containerized or have existing VM images to move the cloud. And then compute engine is a type of infrastructure as a service. So delivering scalable. So macam sebelum saya ada interview tentang cloud, dia akan tanyalah, especially yang soalan yang penting ialah bezakan lah. So explain about infrastructure as a service, platform as a service, software as a service. So tiga benda ni kalau kita boleh explain pada dia apa beza dia, memang cantik lah. So dia basic general question. So ulang sekali lagi, on compute engine is type of infrastructure as a service, delivering scalable, high performance virtual machines running on Google's infrastructure, and compute engine VMs virtual machine boot quickly, come with persistent disk storage, and deliver consistent performance. So you can run any computing workload on compute engines such as web server hosting, application hosting, and or application backend. So virtual servers are available in many configurations, including predefined size. So alternatively, there's the option to create custom machine types optimized for specific needs. So compute engine allows users to run their choice of operating system, either Windows or Linux. So while compute engines allows users to run thousands of virtual CPU on a system that has been designed to be fast and offer strong performance consistency, there's no upfront investment required. So the purpose of custom virtual machine is to ensure you can create a virtual service with just enough resources to work for your application. For example, if you want to run your application on a virtual machine, but none of the predefined versions will fit the resource footprint you require, your application needs to run on a specific CPU architecture, or GPUs are required to run your application. So custom virtual machines allow for creating a perfect fit for your applications. To meet your workload requirements, there are different machine types options that you can consider. A higher proportion of memory to CPU, a higher proportion of CPU to memory, or a blend of both through Google's standard configuration. So compute engines offer predefined machine types that you can use when you create an instance. A predefined machine type has a preset number of vCPU, virtual CPU, and amount of memory. are charged at a set price. So you can choose from general purpose machine types or memory optimized or compute optimized machine types. And predefined virtual machine configuration range from micro instance of 2 vCPU and 8 GB of memory to memory optimized instance with up to 160 vCPUs and 3.75 terabytes of memory. So compute engine also allows you to create virtual machines with vCPU and memory that meet workload requirements. Besides the performance benefit of doing so, this also allows you to significantly reduce costs. So you can create a machine type with as little as one vCPU and up to 80 vCPU or any even numbers of vCPUs in between. So you can configure up to 8 GB of memory per vCPU. So benda ni pun kita boleh custom ikut kita punya needs lah. So for network storage, up to 64 terabyte in size can be attached to VM as a persistent disk. So persistent disks are the most common storage options due to their price. So performance and durability can be created in HDD or SSD formats. So if a VM instance is terminated, its persistent disk retains data and can be attached to another instance. You can also take a snapshot of your persistent disk and create new persistent disk from that snapshot. And then compute engines offer always encrypted local SSD block storage, unlike standard persistent disks. Local SSD are physically attached to the server hosting the VM instance, offering very high input-output operations per second and very low latency compared to persistent disk. So predefined local SSD size up to 3 terabyte are available for any VM with at least one vCPU. So by default, most compute engine provided Linux machines images will automatically run an optimization script that configures the instance for the peak local SSD performance. Standard persistent disk performance scales linearly up to the VM performance limits. So a vCPU's account of 4 or more for your instance doesn't limit the performance of standard persistent disk, and a vCPU count of less than 4, for instance, reduce the write limit for input-output operation per second. So, or IOPS. Because network egress limits are proportional to the vCPU count. And the write limit also depends on the size of IOPS. For example, 16 kilobyte IOPS consume more bandwidth than 8 kilobyte IOPS at the same IOPS level. So standard persistent disk IOPS and throughput performance increase linearly with the size of the disk until it reach set per instance limits. And the IOPS performance of SSD persistent disk depends on the number of vCPU in the instance in addition to disk size. And lower core VMs have lower write IOPS and throughput limit due to network egress limitation on write throughput. And then SSD persistent disk performance scales linearly until it reaches either the limits of the volume or the limit of each compute engine instance. So SSD read bandwidth and IOPS consistency near the maximum limits largely depends on network ingress utilization. Some variability is to be expected, especially for 16 kilobyte IOPS near maximum IOPS limits. So networks in the cloud have a lot similarities with physical networks. So you can segment networks, use firewall rules to restrict access to and create static routes to forward traffic to specific destination. And you can also scale application on compute engine from 0 to full throttle with cloud load balancing. Distribute your balance compute resources in a single or multiple regions close to your users and meet your high availability requirements. And then subnet segments your cloud subnet IP space into subnets. Subnet work prefix can be automatically allocated, or you can create a custom topology. So when you build a compute engine instance, you use virtual network adapter. That is a part of the instance to connect a virtual machine to a network, much in the same way you would connect a physical server to a network. So for compute engine, you can have up to 8 virtual adapters. So all virtual machines are charged for 1 minute at boot time, which is the minimum charge for a VM. So after that, per second pricing begins, meaning that you only pay for the compute time used. So Google also offer sustained use discount, which automatically provide discounted prices for long-running workloads without the need for sign-up fees or any upfront commitment. So predefined machine types are discounted based on the percent of monthly use, while custom machine types are discounted on a percent of total use. And the Google Cloud pricing calculator is a great way to see pricing estimates based on different configuration options that are available under instance. Stool, tenant nodes, persistent disk, load balancing, and load cloud GPU. So nanti please try to create to do this lab. Nanti saya bagi lab credit. So please insert your Gmail or email. You name your email. I think I will use Gmail aku nanti credit to maintain dalam kamu punya email. Faisal. Okay.
Okay, sir.
Okay, saya baru dapat. I think they give me 5,000 credits, which is around $5,000 something. So cuma saya duk test macam mana saya nak share tu. Saya takut tak apa. Nanti email nanti saya share and please update boleh dah dapat belum. Alright. So yang ni lab untuk virtual machine. So let me, by completing this lab, you will create a virtual machine with Cloud Console and create a virtual machine using the G Cloud command line and deploy a web server and connect it to a virtual machine. And our next topic looks at building elastic application based auto scaling. Tadi buat macam mana kita nak create using virtual machine. Sekarang ni bila kita ada virtual machine, kita nak macam mana nak auto scaling, nak naikkan dan turunkan ikut keadaan. So let's look at how auto scaling works. So auto scaler control auto scaler. So Google Cloud pun dia ada buat template dia. Ni compute engine, ni Google scaler semua dia ikut Amazon lah. So auto scaler controls and manage instance group, adding and removing instance using policies. A policy includes the minimum and maximum number of replica. So in this diagram, n is any number of distant replicas based on a template. The template requisition resources from compute engine identifies on OS image to boot and starts new VMs. And startup and shutdown scripts can be used for many purposes. However, in case where speed of auto-scaling is required, it is common practice to bake customization on software installation into the OS image. So use scripts for graceful entry, for graceful entry and exit. So for example, a shutdown script can be used to notify a load balancer that the instance is going out of service and not to send any more traffic. The percentage of utilization that an additional VM contributes depends on the size of the group. So the fourth VM added to a group offer 25% increase in capacity to the group. So the 10th VM added to the group only offered 10% more capacity, even though the VMs are the same size. So in this case, shown in the diagram, autoscaler is conservative and rounds up. In other words, it would prefer to start an extra VM that isn't really needed than to possibly run out of capacity. So actual utilization above 66%. So target yang kita set target 75%. So ditambah lagi 2 to make sure bawah pada target. Okay. Tambah 3 before. So in this example, removing one VM doesn't get close enough to the target of 75%. Removing a second VM would exceed the target. So autoscaler behaves conservatively. So it will shut down one VM rather than 2 VM. It would prefer underutilization over running out of resource when it is needed. So they make sure better of underutilized than apa ni ataupun tak cukup. So better dia lebih daripada kurang, tapi dia dekat-dekat dengan target. So next is we will explore how App Engine can run your applications without having managed the infrastructure. So the second one is App Engine. So App Engine allows you to build highly scalable application on a fully managed serverless platform. App Engine is ideal if time to market is highly valuable to you and you want to be able to focus on writing code without ever having to touch a server, cluster, or infrastructure. So it's also ideal if you don't want to worry about a pager going off or receiving 500 errors and so on. App Engine allows you to have high availability apps without a complex architecture. So as a fully managed environment, App Engine is the perfect example of computing platform provided as a service. Ni yang panggil platform as a service. So App Engine can save organization time and cost in software application development by eliminating the need to buy, build, and operate competing hardware and other infrastructure. This includes no server management and no need to configure deployments. This allows engineering teams to focus on creating high-value applications instead of no-value operation work. So you can quickly build and deploy application using a range of popular language like Java, PHP, Node.js, Python, C#, .NET, Ruby, and Go. So you can bring your own language runtimes and framework. And App Engines allows you to manage the resources from the command line to debug source code in production and run APIs back and easily using industry-leading tools such as Cloud SDK, Cloud Source repositories, IntelliJ, IDEA, Visual Studio, and PowerShell. And App Engine automatically scales depending on the application traffic and consume resources only when code is run. So this allows cost to be kept to a minimum. So you can run your application in App Engine using a standard or flexible environment. You can also choose simultaneously use both environments and allow your service to take advantages of each environment's individual benefits. So the standard environment offer managed infrastructure for your application that can scale down to zero if not in use. So this means you stop paying to use the service. However, your application must conform to the down environment of App Engine standard. Only the specific version of few runtimes is supported, so you cannot log in into the system to make changes. You cannot write to persistent disk, and the progression of environment is limited. For App Engine flexible environment runs your application in a Docker container support. You can use any HTTP-based runtime. The virtual machines are exposed, allowing you to log in into them and write to persistent disk. However, the system will not scale to zero. You will still pay for the service even if the users aren't using your application. So because VM instance in the flexible environments are compute engine virtual machines, there are far more options for infrastructure customization. You are also able to take advantage of a wide array of CPU and memory configuration. So in summary, if you just need a high performance managed infrastructure and can conform to the strict runtime limitation, then App Engine Standard is a great option. If you need to use a custom runtimes, or if you need a less rigid environment but still want to leverage platform as a service, then App Engine Flexible would be a more suitable option. So the front end is often critical to the user experience. To ensure consistent performance, the built-in load balancer will distribute load balancer will distribute traffic to multiple front ends and scale the front end as necessary. So the back end is far more intensive processing. This separation of function allows each part to scale as needed. So note that the App Engine service is modular, and this example shows a single service. More complex architectures are possible. So when using App Engine, you also have multiple options to store application data, including caching through App Engine Memcache. Cloud storage for any objects up to 5 terabytes in size. Data store for persistent low latency memory for serving data to application. Cloud SQL, which is a relational database that can be run on a persistent disk greater than 1 terabyte in size, and Cloud Bigtable, which is a NoSQL database for heavy read and write analysis. To automatic scaling of App Engine allows you to meet any demand and load balancing distributes a load balance compute engine in a single or multiple regions close to users to meet high availability requirement. So with App Engine, you can easily host different versions of your app, which includes creating development, test, staging, production environment, and Google Cloud Operations Suites give you powerful application diagnostics to debug and monitor the health and performance of your app. You can leverage robust security tools like Cloud Security Spanner. So yang ni app version ni macam ni lah. Kadang-kadang kita buat in the latest one not working, so kita boleh roll back, kita ambil yang working sebelum ni. So all of these provided with high availability and guaranteed redundancy. So we will create a small App Engine application that displays a short message. So please do that after this. I think let's stop here and continue later. Okay. Right. Ada soalan tak? Anyone have question?
Tak ada.
Okay, thank you. Thank you for joining. So
Thank you, sir.
have a good rest.